Vijayalakshmi, ma'am, we'll start. So we'll just have the introduction. In meantime, participants will join, ma'am.
Yeah, okay, fine.
Okay, thank you. Good evening, all the participants. I welcome for the day 5 session of the ATAL FDP. So it's my privilege to introduce Dr. Vijayalakshmi MN ma'am. So Madam was one of my co-guide as well. So means with Madam we have worked nearly 10 years back for my PhD work and all. So I was associated with Madam. So it's really my privilege to introduce Madam to all the participants of ATAL FTP. So Dr. Vijayalakshmi MN has accomplished academician and researcher, currently working as a professor in Department of AI and ML, RV College of Engineering. So Madam has having nearly 2 decades of rich research and teaching experience and leading with various academic leadership. She holds PhD in computer science and has strong experience in data analytics, artificial intelligence, machine learning, and image processing, with an impactful application in healthcare, smart system, and environmental analytics. She has an extensive publication record comprising numerous journal articles, conference, book chapters published at reputed IEEE, Springer, Elsewhere, and Scopus Index journals. She has also successfully led funded research project and industry consultants assignments in data analytics, visualization, healthcare, signal processing, and AI-driven system. Dr. Vijayalakshmi has received several prestigious awards, including the Outstanding Scientist Award and the Best Indian Citizen Gold Medal Award, recognizing her excellence in research and higher education. She actively contributes to the academic community as a editorial board member, reviewer for IEEE conference and journals, and technical program chair for various international conferences. A dedicated mentor and educator, she has successfully supervised PhD scholars and numerous undergraduate and postgraduate projects, while also playing a key role in academic administration, curriculum design, accreditation, and industry collaboration. So I request all the participants to kindly please join with me in warmly welcoming Dr. Vijayalakshmi MN for today's session. Thank you all. Ma'am, so over to you. So you can take over the session.
Okay, thank you, Manju Prasad, for giving a introduction, and even I am happy to share that as for Manju Prasad, I was a co-guide during his PhD also, and it was nice working with him and getting to know more about his work. So I'll be sharing my screen. Manju Prasad, I'm not able to share the screen.
We'll be making you as a co-host, ma'am.
Yeah.
So along with me, I have Dr. Arpita Shankar, who is the main coordinator of this FTP, ma'am.
Okay.
So Madam is the coordinator for this one.
Sure.
So Arpita, ma'am, can you make Madam as co-host?
Yeah, done, sir.
Yeah, okay, fine. Yeah, I'm able to.
Share the screen.
Yes, I'm able to. 1 minute, let me. Okay, I think now my screen is visible. Yeah.
Yes, ma'am.
Now also the slides are visible.
Yes, ma'am.
Okay, fine. Yeah. Good evening, all. So it's my privilege to be as a speaker for this ATAL FTP on ROS2 integration with artificial intelligence. So you know who I am and all. So let us start directly with the presentation, whatever we have today. So the major topic of mine will be how we can integrate AI with ROS or robotic operating system basically. So the entire agenda of my sessions will be with respect to this, like in what way, how AI can be integrated, because AI is playing a very major role in every aspects of life. To think of any domain, AI is taking over. So in what way AI can be contributing, it will be contributing to ROS. So by this time, I think you all know that what is ROS is all about. Okay. So basically, it is a robotic operating system, especially which is well designed for rapid advancement of robotics and automation. So we all know that nowadays everything is being taken over by AI, and basically it is the need for automation there. So this robotics and automations are basically improving, gives improvement in the different computing power. And you all know that when we talk about automation, something will be there wherein the collection of the data comes into picture. So the data is the one which plays a very prominent role. So the collection, the data can be collected or can be used in N ways. So among them, one of the ways is through collecting the data through sensors. So, but when you have collected the data to through sensors, maybe or in any other way of collecting it, we have to do certain insights, or we have to draw certain insights out of it, and we have to perform certain analysis on that, where these AI algorithms plays a very important role, and through which we can achieve the automation there. And of course, the connectivity between the application and the data collection is very, very important. So that is what is the major emphasis will be there with respect to the automation also. And then nowadays, you all know that earlier when we used to tell robots means they were only limited for the factory automation, isn't it? So everything was handled in any industries, major industries. Robots were used in doing certain tasks. But nowadays, you think of a robot, everywhere it is being used. Think of a domain, it may be used in health sector, or it can be used in agriculture, logistics, defense, and smart cities. So how do we make these robots intelligent is the need of an hour. Okay, so many, if you see many abroads and all, the usage of robots are happening at very large scale, but still it is not so up to the mark. So we all know everything, but still how well it can be optimized. Okay, because the entire thing of integrating AI to any of the system will be how best it can be optimized. That is what is the major the thing we have to concentrate on. And then there is a huge demand actually. Okay, so for all these, software framework which can actually handle the complex operations where the robo operations are involved, because we know that when we say it is robotic, very, very complex operations are being involved. But how AI can contribute in executing these complex operations which the robo handles is the one which is the need of an hour. And then there is a huge demand for the intelligent autonomous robotic systems. Okay, so as you all know that the traditional robots which were there were heavily, they were basically relied on some pre-programmed instructions and human supervision, because one or the other human should be there in supervising how best the task assigned to it can be handled. Okay, but now that is not the case. Everything is done automated. Okay, everything is automated such a way that automation is being done through AI. Okay, so this is the need of an hour, and this is the growing demand for robot, where how well they can perceive, and also understand the environment in which they are working. Because when they get to know that the environment in whatever they have it will be easy for them in making decisions. Okay, so and you know that the environment in which we live is dynamic in nature. So dynamically, the robot should take decisions such that the assigned task is being achieved in a very efficient way. So that is what is the main need with respect to automation. And also this can be achieved. Okay, so the automation, whatever we are speaking, isn't it? So this can be achieved from the data, whatever is being fed, and through the learning and the experiences, whatever it is, such that, okay, such that it helps the robot in making the decision independently. Okay, and the autonomous, the robotic systems, whatever we have, okay, so these systems should be developed, or it should be generated. I think it should be developed in such a way that it should be safety also, and it should be scalable. Okay, so that is what is the major need we have to take into consideration. And also where actually all these applications lies, the numerous applications are there wherein these robotic systems can be made used of. And then the major, I can say, the need now at this particular century, whatever we are, is the integration of this robotic operating system with the AI. Okay, because AI is the one where the entire automation will come into picture. Not only automation, earlier also automation were there, but through AI integration, the system will become more, okay, dynamic in nature, okay, where its efficiency, working efficiency will get increased. Okay, so why there is a need for integration of AI with ROS2 is that ROS2 is explicitly just a middleware based framework explicitly for robot communication and control. So as you all know, this is, I think this may be the 5th day on which you may be attending this FDP. You may be knowing what is this ROS is all about. Okay, so where it is just a middle-based framework which has some communication and controlling systems through which a robotic systems can be developed. Okay, but with the integration of AI, right? With the integration of AI, which actually helps this ROS in perception, which is through computer vision maybe, or it leads for prediction and adaptation, which can be done through machine learning algorithms. And very important is that it helps in decision making. Okay, which helps in decision making, which can be done through what is called as reinforcement learning. So basically, when the integration of AI comes into picture, these three things, not only these, many other, but these three things of AI will play a very, very prominent role, where through computer vision, okay, you can perceive the things. Okay, through machine learning, you can speculate, and through reinforcement learning, which helps in decision making. So the integration of all these things into this ROS, okay, will help the robots to operate in dynamic environment, because as I told that the robot should perceive the environment also in which it is working. So through integration of this, it will help in dynamic environment, and also it can handle any uncertainty things which suddenly happens. Okay, and also handle any unstructured environment. Okay, so together all these things will be actually the backbone of what we call it as next gen robotics. Okay, so the next gen robotics is nothing but the integration of AI into already existing ROS, whatever we have. So, and the other important thing what we have to look into is that how well these systems can be scaled up. Okay, how well these systems can be scaled up such that the tasks whichever will be done by a single robot can be done through multiple and large robots. Why? Because there are certain tasks where multiple robots has to coordinate among each of them and then perform certain tasks. So this integration of AI helps in coordinating among the robots such that, okay, the task can be done in an effective way. So these there may be a critical environments existing in industrial environment maybe, or in any of the medical or some safety and critical environment where the integration of two or more robots or coordination of two or more robots is very, very necessary, such that all the tasks or all the jobs assigned to those robots can be done in a proper way. Okay, and since ROS, as you all know, is mainly meant for distributed architecture and with the fault tolerance, the integration will be helping in solving the complex solutions in giving a proper way. And also,
Excuse me, ma'am.
yeah,
Sorry to interrupt. Are you changing the slides, ma'am?
yeah, I'll be
They're,
changing.
asking for-
I'll be changing. Yeah,
No, it's
I'm
in the
still,
introduction
yes,
slide
yes,
only.
yes. I'm in introduction slide only. I'm not changed. Yes.
Okay, ma'am. Thank you.
Yeah. Fine. Okay. So this is what is to deal with the introduction, where the entire, the robotic operating system, the need for robotic operating system and the AI as such. Now, coming to the integration. So let us just get to know what is basically AI is all about. Okay. So little bit just brief, okay, in a superficial level of telling what is AI is nothing but is a branch of computer science that mainly focuses on creating systems of machines capable of performing tasks that normally require human intelligence, such as learning, reasoning, problem solving, perception, decision making, and language understanding. So all these things, tasks are basically humans who do take care of it, but so when it is being done by machines, how it can be done? So how do we make those machines to do these different tasks wherein human does is what is AI is all about? So in a simple definition way, we can tell that AI enables machines to think, learn from experience, and act intelligently. So that is what is the major goal of AI in making machines to do these tasks. And then what and all AI can do, that is what we should know. So, okay, basically there are certain things where AI can't do, but we are focusing here is what and all AI can do. It can learn. Okay, so it can learning. Okay, but from where it is going to learn? Of course, to do any task, it has to learn from the data, whatever it is fed into. Okay, so like so when I compare this with human, okay, we learn through our peers maybe, or when we are small, we learn through our parents, where our parents guide us, so we learn through them. And as we grow up, we learn from the environment and everything. Similarly, AI system also should learn, but on what they are going to learn? They are going to learn through the data, whatever is being fed for them, and it should improve the performance over time. Okay, it should not be the same thing. See, as we grow up also, when I compare that with human, as we grow up, okay, our thinking capability, everything keeps on changing over the time. Similarly, we keep on improvising. Similarly, AI system also should improve as and when the time changes. That can be achieved through machine learning and deep learning techniques. Okay, then AI can do reasoning and decision making. Okay, so again, contrast to humans, human also can do this, where they can do reasoning and decision making. Similarly, AI also okay, can analyze information, draw some logical conclusion, and depending upon those conclusion, it can also do certain decisions based on certain probabilities or rules or some methods. Okay, next is AI can do certain problem solving. Okay, so it can help in solving complex problems. Okay, and it can also evaluate the outcome. Next is perception. Of course, it can interrupt the data. Okay, maybe the data, we know that there are basically different types of data. So whatever may be the type of data, whether it is structured, unstructured, or semi-structured data, it should take those data, perform certain okay, analysis, and interpret on what is that particular data is all about. So this is achieved through something called as computer vision and speech recognition. So natural, and the next one is natural language understanding and generation. So AI can understand, interpret, and generate human language enabling chatbots, translation system, and voice assistants. And the next one is it can do something called as pattern recognition, where it can identify the trends in the large data sets which are useful in fraud detection, explicitly in these areas, okay, where it can be used in fraud detection, maybe with respect to credit card or so, and then it can help in medical diagnosis, and also in something called as recommendation system as well. So these are the things where AI can do. So and then, but to do what AI can do is to do all these things. Okay, this is simple pictorial representation of what humans can do, what AI can do, combined together, how it will be helping up. So as a human, okay, we can do okay, marketing can be done. Okay, so these are some of the, I can tell it as, these are some of the skill sets which is being required, okay, for performing certain AI task as such. Then proceeding ahead, when everywhere AI is being used, okay, everywhere AI being used, then what is the major challenges which can arise when we try to enforce AI into it? One is, so we are here, we are talking this in terms of, you know, three aspects. One is with respect to data. So as you all know that basically to do any task through AI or ML maybe, data is very, very necessary. Okay, but without data, it can't do anything. So the more emphasis will be on the data, but with respect to data, the data quality and the quantity in which those systems are trained, right, will be necessary, is very much necessary. So if the data is not up to the proper quality, okay, the decisions, whatever it has been given by AI, may not be appropriate. So the data on which those AI systems are trained is very, very important here, and the quantity in which the data is trained, that is also very, very important. And but to do all these complex systems, naturally we require computational requirements is necessary, where the computational systems, high-end servers maybe, or high-end systems which can handle this huge voluminous data is very, very important. Next is with respect to data is, of course, nowadays everything is happening in real time. So real-time processing, so many constraints do come into picture, but how these AI systems can handle those constraints in real time with respect to the data, that is also is very, very important. And as and when we tell that more and more the AI systems are there, most of the AI systems lack these explainability and transparency, because nowhere anything goes wrong. Okay, none of the systems are accountable. We can't blame because of AI this has happened. Okay, like for example, we have an autonomous vehicle. If suddenly any accident happened because of it, who is accountable? Whether it is the system engineer or the factory who assembled it, or it is accountable for the software who developed? No, nowhere such a kind of a rules or laws are existing where this accountability will come into picture, and what is happening inside, nowhere we don't know. Transparency is not there. See, like transparency with respect to this, suppose if you want to go for, I mean, if you are browsing any website, suddenly you may be getting some messages. No, okay, you hereby abide by rules and regulations, I abide. But we normally don't read it. We just simply click it and we proceeded. Okay, but what is that? What happens inside? Whether how those things are changed, how the decisions are being done, those transparencies, those kinds of actions, nowhere we are getting to know. That is what we mean by telling transparency. And data should be in such a way that it should not get biased. Okay, the AI system, whenever it is being developed, it should not get biased, and it should have certain ethical concerns also. So these are the things, challenges we may come across whenever we are developing or we are taking up AI as a requirement. And then coming with respect to the people, there are some lack of understanding of AI among non-technical employees, because most of the technical employees know AI. I'm not degrading them, but still many people, okay, many people doesn't know about what the capability of AI, without which, okay, they may fall for any of the other actions. Like you may be looking into papers, news, and all. So many cybercrime thefts are happening. Now, we had something called digital arrests and all. Okay, both it is for both the literate, educated people and non-educated people. Also, it was happening. Okay, but still that that concern. Okay, the understanding of what AI can do is not known by many of the people, and there are certain scarcity in these areas also with respect to people. All people doesn't know everything. Okay, but still that is one of the concern with respect to the people which we have to look into. Then coming to the business perspective, whenever there are these AI systems involved in whatever the area it is or in whatever the way it is, high implementation and maintenance costs will be there. Why a high implementation and maintenance costs? Is because those complex systems will be working on a huge data, and naturally they will be processing a complex algorithms, maybe complex they'll be able to do certain complex problems. So every time they have to be keep on maintaining them. So maintaining cost also will be very much necessary. And depending upon the need, okay, depending upon the need, it has to get scaled up. To scale, new hardware requirements may come, so which in turn increases the cost. So that is what it is. And of course, data availability and quality issues will be there, and lack of skilled workforce is there. Integrating with the existing system is one of the challenging with respect to business. Why? Because suddenly you can't integrate, because most of the people will be trained for the good old systems which they might have used for 10-20 years. Suddenly, if you tell to change over, it becomes a little bit difficult for them for getting to adjust it. And of course, there are no any ethical, legal or compliance risk, and many doesn't have security and privacy concern, as I told. Okay, so these are the major challenges. Okay, these are the major challenges which comes into picture with respect to AI whenever it is being used. So we have discussed, I mean, we have shown only with respect to these three aspects, but apart from this, there are many aspects on which the challenges may come into picture, but these are the main thing which I thought, so I'm just putting it forward to you. Next is, what is ROS? So you may be knowing about it. So it is first of all, it is an open source middleware framework for robotics, where it acts as a middle layer between robot hardware and high level application. And it simplifies the tasks such as sensor communication, maybe control perception on data exchange as such. And then it is a successor to ROS Okay, so ROS2 is the next generation version of ROS. Okay, so addressing the limitations whatever it had in ROS1 as such. So you all know what is that, and then it improves reliability, scalability, and robustness. And then basically ROS2 is designed for modern distributed robotic system where it is capable to build and support distributed multi-node and multi-robot system, and it uses DDS, that is data distribution service, for peer-to-peer communication. That is what is the main heart of ROS2, I can tell. And basically it is suitable for cloud robotic and all. And then of course ROS2 supports real-time and production level deployment, where it has its built-in security, fault tolerance, and it has QoS controls, which is suitable for safety and critical applications as such. So this has that is what is to do with the ROS2. And then what are the key features of ROS2? So you all know that it is DDS-based communication, where it uses data distribution service for as a communication in the middle layer, which is basically it is decentralized. That is what is the main key feature here, because since it is not, it is fully decentralized. Okay, so there is no any central master services as there. It supports something called as publish, subscribe, request, reply, and all. And then it is provides high configurable quality of service and all, which you all know. And then it has got real-time capability, which reduces latency and jitter in control flow. And then another important is multi-platform support. Yes, as you all know, it supports different platforms, which is supported by Linux, Windows, and Mac OS, which depends upon the need you can make use of. And then it improves, which actually in turn improves portability for these robotic applications. And of course, it has got built-in security mechanisms, where it has got authentication of nodes and then encryption, communication, and all, and which also helps in scalable multi-robot support it has, where it supports large-scale distributed robotic systems, and which enables coordination among multiple robots and facilitate reliable inter-robot communication in a dynamic environment. So these are some of the key features of ROS2. Now, this is what is the ROS architecture is all about. So where at the base layer, at the lower level, you have the OS layer. So basically, as I told that it will support interoperability. It can be used in Linux, Windows, and Mac OS, any of the OSs. So here it is the Linux OS which is there. So in the middle layer, you have this DDS, which is distribution data services, which is which enables actually the decentralized way. And then you have abstract DDS layer, and you can use different libraries which can be made use of. And at the top you have your application layer. Okay, so you have different nodes, wherein each one is an individual application through which these accessing can be done. So this is what is the basic ROS architecture, whatever we have. Then why this ROS came into picture? Okay, why? Because of the limitation of the traditional robotics system. So basically, what is the major traditional robotic system came up is because of all the traditional robotics were pre-programmed, and they had what is called as rigid behaviors. So means, what do we mean by this actually? What we know that they are pre-programmed and rigid behaviors, but actually what do we mean? So all the traditional robotic systems, whatever it was there, they were basically on rule-based and hard-coded instructions. So everything were hard-coded, and it was entirely on rule-based. And then they followed certain some predefined paths or actions. So this is the way it has to be done. Means that is the way only they were doing, irrespective of whatever may be the case. And then they were not able to learn with the experience, okay, or improve over time. Okay, so that was not there, because that is what is required now. Dynamically, the environment changes. So depending upon dynamic environment with the perception, okay, the system also should change and take decisions dynamically. But the traditional robotic systems, whatever were there, robotics, whatever were there, they were not able to do that. That was the major, I can tell it as the major limitation of robotics. And then any change in the task or the environment, there were manual human intervention was there, because humans should interfere and change the environment and reprogram it such that it would adopt to that particular environment. That was the one of the thing. And then there were coming to the second point, poor adaptability to dynamic environment. That is what is again one of the limitation of traditional robotics, whatever it is. Means, what is this poor adaptability to dynamic environment is? So all these traditional all these traditional robotics, whatever were there, they were basically designed mainly for structured and predictable environment. Okay, so the environment was fixed. Means it was not adapting to the changing in the environment. That was the thing what we mean to say here. And then their performance were degrading over the time. But normally it should happen such a way that the performance should keep on improving over the time, but their performance was degrading. But what is the reason? What is the reason why the performance was degrading? Is because of the environmental change. That is one reason. The other reason is there were so many, they were not getting accustomed to the uncertainty behavior. Okay, so that is what is the thing which made their performance to degrade, because as and when suddenly the uncertainty may happen, so how well it is adaptable to that uncertainty in event, that was not there with the traditional robots. And then of course they had limited perception and reasoning. So they were in the earlier robotics, where they had the inability to understand the complex scenes or contextual information. Depending upon that, they were not able to do, and they had limited object recognition and localization and scene interpretation, and they were not able to perform any high level reasoning and all. So, and majorly it was all human intervention. So continuously human intervention was there, where because of which the manual errors were causing, which limited their performance as well. So this is what is the major limitations were there with respect to the traditional traditional robotics. Now next is how I can integrate AI, okay, with robotics. That is what we'll try to get to know. Okay, so since we till now, okay, before this, any questions if you have, I can take it up now for the things whatever I handle before moving ahead. Any questions till now?
Participants, any questions?
Till now?
No, ma'am.
Yeah. Okay. Fine. Fine, thank you. Okay, now let us try to see what is the role of AI in robotics as such. How in robotics, basically, how we can integrate AI. That is what let us try to understand. So, as we all know that whenever AI is integrated, it enhances perception and understanding. Correct? That is what is the need of an hour, need of the hour now, because it should perceive what is happening, learn through the context, learn through the environment, and understand properly. That is what. And then another important thing it does is it enables learning and adaptation. Yes. Okay. So through AI, the robots can learn very well and adapt. Okay. Adapt to the, adapt to what? To the environment change also. Fine. Then improves autonomous decision. Yeah, this is also one of the important, I can tell what it is. The involvement of AI will help it out, where dynamic change in the environment, everything, okay, through AI, okay, through AI, it can be done, and it facilitates, it facilitates the human robo interaction. Okay, so as much as possible, the human intervention will be less, but still, but still you can have human intervention, but somewhere the human intervention will be there. So now coming to the overall, the overall role of AI in robotics, when we look into how actually the flow of robo will be is, first of all, it will be the sensors, isn't it? Because whenever we tell that a robo is doing certain task means it should get the data, isn't it? It should get the data, and then that data has to get analyzed. Okay, that data should get analyzed. Then so how do we get that data? Okay, so it can be through cameras or through some sensors. Okay, so through them the data is being taken. Next is perception. Okay, so it has to understand that particular data. Okay, it has to understand that particular data. So where here in this layer, or I can tell it as this perception layer only, AI is going to play a role. Okay, in this perception layer only, AI is going to play a role. Okay, so through AI, how do we perceive the data, whatever it is being received? Okay, how do we understand that particular data, whatever the data it is being got? How do we look into the environment also contextually? How we can look into that particular environment? That for that, AI is being used. And then once understanding what is the data, understanding the perseverance of the data, naturally that data has to be learned, get to know. So to do that, okay, for learning that, right, for learning that, you can make use of what we call it as machine learning and reinforcement learning. So this also is a part of AI. Okay, so this is also, whatever it is, this is also a part of AI. So for perseverance, perception, and for learning, for both the case things, AI can be made use of. So once it is learned, okay, once it is learned, naturally we have to take certain decisions. Okay, so that is being done through a planner, which is again a part of AI, through which a planning can be done where AI get integrated, or I can tell it as AI is going to play a role here. And finally, actions are considered. Actions will happen. Okay, so this is how I can tell it as a flow of, okay, flow of AI integration in robotics. Okay, so robotics means what? It is entirely take the data, understand what it is, learn what it is, and take decision and go ahead, whether to move or not, whether obstacle is coming suddenly. Okay, I should stop. But that is being done through the learning. So where that learning happens through this AI as such. So through AI, it is perceived. Okay, so sensors is the one where actually the data is considered. So you all know that to do any complex calculations maybe, or to do any decisions, to take any decisions maybe, data is necessary. So how do we get the data? Again, through cameras or through sensors, because the entire robotic system is made up of sensors and cameras only, wherein it can do certain, it can collect the data. So since we all know that sensors are the one which actually, through which we can collect the data. So after collection, okay, naturally we have to understand it, so and learn it. So to do both these things, that is the perception and the learning, AI and ML and RL are the one which helps us in doing it. Okay, and the planning, decision, whether to go ahead or not. And finally, it is the action which is be done. Okay, so this is basically the role. Okay, this is basically the role where AI is going to play in the entire robotic system. Then again, that I can again link with our ROS, whatever we have. Okay, so since we all know that ROS is the collection of the DDS, the middle layer, the application layer will be the OS, the middle layer will be the DDS or abstract DDS and some interfaces, and at the top level it is the application layer, where it is a collection of nodes, where each node is an independent system maybe, or independent program maybe, which does its own tasks. Okay, so if I take if I make an analogy, you know, if I make an analogy between, you know, between these ROS architecture to our human, so this is what is the analogy I can make, where the inference, the AI inference node, whatever we have, so this one, whatever it is there, that I can link to our brain. Okay, so then that ROS controller node, whatever it will be there in ROS architecture when we talk about, okay, that I can link to our nervous system, and the drivers, the actions, whatever it will be doing, that will be done through our muscles. So a simple analogy I can give with respect to our structure of our human body with respect to the ROS as such. So this is where actually, you know, this is where actually the AI, the role of AI will be there whenever you talk about in terms of robotics as such. Okay. Next is AI techniques in next gen robotics. Okay. So what are the different techniques? What are the different techniques which are there in AI, which helps us a lot, okay, in making our robot, okay, learn from the environment, become more contextual and all is because of these different techniques within AI. So this is a simple diagrammatic representation, how through a Venn diagram, okay, or I can tell it as through some concentric circles, what each technique mean. Okay, at the top level, okay, we have AI. Inside it is something called as machine learning. Inside we have something called as deep learning. Okay, so we all know nowadays AI, ML and data science is a buzzword everywhere it is going. What is data science then? Or else I can tell that how do we differentiate between AI, ML and data science? Is the intersection of the statistics, math and visualization, or EDA, whatever we do with AI, ML will become our data science. Okay, so this is one set. Maths and statistics and visualization is one set, and this is another set which has AI, machine learning and deep learning. The introduction of two is our data science. Means to do data science, okay, to do data science, you should be knowing the statistics behind it, okay, and then math behind it, and you should be knowing even AI, ML. Okay, so together will be our data science as such. Okay, now visualization and EDA. Let us try to understand, these terminologies more, because when we say AI or ML, AI and ML rather, okay, these terminologies are very, very important for us. Okay, so math, of course, the need for math and statistics with respect to data science maybe, or with respect to AI, ML is very much necessary for us. Why? Because when we speak in terms of AI or ML, there are so many different, I can say, algorithms which have been involved within which, where to get to know how those algorithm works, to get to know how those algorithm works, we should be knowing the math behind it, okay, and the statistics of it, and visualization. So and now visualization is also going to play an important role. Now, how visualization is going to play an important role is going to play an important role through our what is called as that EDA. Now, what does that EDA stands for? Is exploratory data analysis. Now, what do we mean by that? Exploratory data analysis. That is what is the initial step what we do in building a model. Now, what is that? Initial step means, what do we mean by that? Is, as we all know, right? As we all know that whenever we are building any complex systems using AI, data is going to play a very, very prominent role. And as we saw that one of the major challenges in AI is with respect to data quality and quantity. We saw already. So to do or to build any complex system, since data is playing a very, very prominent role, naturally it becomes very much necessary for us in understanding what is the type of data it is. what data it is all about, what it is, how the values are. Okay, like for example, if to start off with only, Manju Prasad gave my introduction there. Okay, wherein what was the necessary of it is that to get to know about me to you people, so that even you will be aware in getting to know who is the speaker, what it is, so on and so forth, so that okay, it helps you in getting to know the things in a better way, isn't it? So similarly, to build any model or to develop any system, especially when using AI, okay, since data is playing a very, very prominent role, knowing about the data is very, very necessary. So that is achieved through what we call it as exploratory data analysis. Okay, so that is achieved through exploratory data analysis. Now, as the name tells, it is exploratory data analysis. Now, what analysis you achieve without AI, you may ask me a question here. See, since I told that the major prominence is given for data, when we get the data, the quality is going to be a very, very challenging task. Since the quality word itself is abstract in nature, we can't define a proper definition. We don't have, or I can't define that, okay, whatever the data I receive is of such a very good quality. But then how do we measure that is the question there. Okay, that measuring, we do through this data analysis or exploring the data we do and get to know about the data. So we give the term as exploratory data analysis, where the data may not be, when do we tell that the data is not of good quality? Is when we have certain outliers present within it or some noise present within it. Okay, again, to give an analogy to it is like, for example, whenever we are listening to music, okay, it will be very pleasant to us and everything. Suddenly some distortion will happen, means that is because of the noise present, isn't it? Which actually will not be the melodies, music, whatever. It distorts the entire music flow. So similarly, the irrelevant data, whenever it is present for a specific task, okay, that becomes our outlier maybe, which actually will affect the model performance. So to start off with any of the model, it becomes very much necessary for us in identifying those noise maybe or those outliers maybe, such that we can remove them and then build a model which will be helps us in making the model work in a very effective way. Okay, so to get to know about those things, okay, we do that, what we call it as exploratory data analysis, and that is achieved through visualization. So we draw certain images, we draw certain graphs maybe, okay, we draw certain graphs, we draw certain images, and we get to know what are the outliers, how the data is distributed, what is the noise present. Okay, there may be certain missing values present in the data, whichever may be the type of a data. Like for example, you may be thinking how a missing or an outlier will be there. Suppose take an image which is an unstructured data. In everywhere the image, think that it is entirely a color image, okay, where the background is the background of that particular image is a black in color. Somewhere you have a pixel which is white in color, naturally that becomes an outlier for us. Of course, it is measured in terms of pixels only. it is measured in terms of pixels only. So somewhere the entire background is in black color, somewhere one dot is there which is in white color, means it indicates it is an outlier. So those kinds of data naturally will be affecting the model performance, which has to be taken care of. That is achieved through the EDA process and through visualization. So visualization and EDA process, okay, again plays a, I can tell it as very, very prominent role in identifying, or I can say getting to know about the data on which it is working. So only which enhances, which in turn, okay, enhances the quality of the data, which in turn, okay, helps the AI system in making the decision in a proper manner. So that is how we can give the link between the data as well as the system as such. Okay, so that is what is to deal with visualization and EDA. Now coming to the different AI techniques which can be applied in next gen robotics are, as I told, one of the first technique is machine learning. Okay, machine learning, as you all know, is which helps in machines to learn on its own. Okay, where we train the machine on some data, historic data we call it as, and then depending upon that, the model will be developed and then certain results will be given. Okay, so basically just to touch upon machine learning, we have basically two types of, I can say, we will be categorizing machine learning into two different categories. One is called as supervised learning and another called as unsupervised learning, where supervised learning gives basically emphasis on the data which has labeled data, but whereas unsupervised learning will emphasize on the data which is not so labeled. So again, in machine learning, in supervised learning, we can perform certain tasks on something on classification and regression and all those things. Okay, so basically using machine learning, okay, using machine learning, we can build a model. Okay, we can build a model. Sorry, some noise is there. Anybody who has unmuted themselves? I'm not able to. Hello, am I audible?
Yes, ma'am, you are audible, ma'am.
Yes. Okay. Okay, fine. I'm hearing some noise at the background. I don't know. Yeah. Okay. Yeah. Now it is not there. Fine. Yeah. Thank you. Okay. I hope now I'm audible.
Yes, ma'am, you are audible, ma'am.
Yeah. Thank you. Fine. So that is what is the machine learning part is all about, where it is you can have a supervised way of learning the model or unsupervised way of learning a model, where we have different types of algorithms or what we call it as machine learning algorithms through which through which the model can be built, and then the model performance can be measured. Also, many different metrics are there through which we can evaluate the model performance. Okay, so one of the techniques for next gen robotic is, as it is, machine learning. Then the another technique is deep learning. Okay, so it is, as the name suggests, it is deeply learns the things, because learning is again learning the data. So where majorly deep learning will be majorly on majorly on CNN and RNN, or what we call it as convolutional neural network and recurrent neural network as such. Fine. So using this, right? So using this also, the model can learn on its own depending upon the data, whatever may be the type of the data. Okay, so it can be structured or unstructured, or when I call it is unstructured, you can feed images, text and all. So basically machine learning, major emphasis will be given on structured data, okay, which will be in the form of a CSV files or so on and so forth. But whereas when we talk in terms of deep learning, major emphasis will be given on unstructured data, maybe a text, maybe an image, maybe a voice, you know. So when you want to train, and get to know, get the model performance and take certain decisions about the data. So when you have basically these unstructured data, so deep learnings are well known used where they are a part of what we call it as the CNNs and RNNs, whatever we tell, they are the part of this artificial neural network where it is again has so many other concepts like hidden layer, okay, input layer, output layer. In each of the training, we have certain activation functions which have been involved. So many things are there. So considering all of them, it is the deep learning where basically is a next gen techniques, whichever it will be used as such. Then next AI techniques, what we have is the reinforcement learning. Okay, so reinforcement learning is another important technique in AI where it is enhances the decision making in a better way. Okay, and then we have something called as computer vision. Why? Because mainly in robotics, whenever it is moving or something, okay, it has to identify the objects, which, okay, if suppose if there is suddenly an obstacle coming, it has to identify that it has an obstacle. So this through computer vision, okay, it helps in identifying those objects which are there and classifying those objects and all. So that is achieved, you know, that is achieved through this computer vision, which is again another technique which helps for next generation robotics. Then another important another important AI technique is natural language processing, which in short we call it as NLP. Okay, why this is necessary? Why this is natural language processing? Why it is necessary? Is basically because the entire AI system, whatever we have, isn't it? The entire AI system, whatever we have, is entirely dealt on the data on which it is working. So when we tell that it is having the data, right? Whenever we are telling that it is the data here, so the data can be of any type. Okay, it can be an image, it can be a voice, or it can be a text. Okay, it can be a video, audio, anything can be done. So depending upon the type of the data, how it gets processed, that is what is very, very important to be noted on too. So whenever there is a textual data given, okay, through this natural language processing, okay, you can train the model and come out with proper insights. Okay, so the text data will be, so whenever the text is being given, it undergoes various process of what we call it as stemming, okay, removal of stopping words and all. So many different steps it undergoes, and finally it identifies the proper text, whatever it is being given, and then the respective action is being taken. Okay, so basically I can tell that in robotics, okay, the integration of AI will be through these different techniques. Either it will be integrated through machine learning, okay, where it can do either all classification, okay, regression techniques, everything can be involved, or it can be done through deep learning techniques where the CNN and RNN will get involved, or it can be through reinforcement learning or computer vision or NLP. So combining all these together, okay, involvement of AI comes into picture, where the robots can perceive very good properly, adjust to the dynamic environment involved, okay, adjust to the dynamic environment such that, it helps in taking the decisions effectively. Okay, so this is how the different techniques can be involved here. Next. So in the previous slides, we got to know what are the different techniques. Okay, what are the different techniques in AI which are very much necessary for robotics. Now, let us try to understand how we can integrate, right? How we can integrate AI with ROS2. Okay, so till now we got to know what is ROS, and also we got to know what is the architecture of OS, the need of integrating AI with ROS, okay, and what are the different techniques of AI can be integrated with robotics, we got to know. But now let us try to understand, okay, now let us try to understand basically at what stages of ROS or robotics, okay, we can integrate AI. Okay, now as we know that ROS is a combination of DDS, the abstract DDS, and the application is entirely on nodes. The AI major integration will be with respect to those nodes only. Okay, wherein each of those nodes are independent programs. They are independent programs which learn on the data whatever they receive. Since if you see the architecture, whatever we discussed, the nodes are at the top layer, or basically the application layer, from where the data is perceived, or I can say from where I can tell the data is received, isn't it? So at that particular level, okay, only the AI models are implemented, and as that is what we tell that ROS2 nodes. Okay, so there only majorly the integration of AI comes into picture, where so the sensor data, whatever is there, is fed onto those learning models. Okay, so because through data only it has to learn, isn't it? Through data only it has to learn. So to learn that particular data, or to get to know about that particular data, AI is integrated, or through AI, I can put it, I can tell in the other way as that through AI, okay, the data, whatever is being received, is trained and learned such that it can give a real-time inference. Okay, ultimately it has to give certain inference, or certain actions has to be taken, or certain I can tell some decisions has to taken. Okay, and that too in real time, isn't it? So that is achieved through this learning models only, which are nothing but the ROS2 nodes. Okay, I hope you are getting a picture where actually the main AI integration will be happening in ROS2. Okay, and of course the feedback has to be given. Now the need for feedback. What is the need for feedback? The need for feedback is it has to improve, right? It has to keep on improve over the time, and then perceive with respect to the environment also, isn't it? It has to do the perception with respect to the environment and get adapted. Adaptability is also necessary, isn't it? it should get adapted to the change in the environment also. So since these things, right, since these things are going to play a very, very important role in any of the robotic systems, okay, feedback is necessary, because depending upon the feedback only, the system will keep on learning. So the feedback loop is also necessary. Okay, so at these stages, the AI techniques can be integrated. So basically, at ROS nodes only, the integration is going to happen. Then how this integration is going to happen? Okay, how this integration is going to happen, right? So this integration is going to happen through something called as TensorFlow, PyTorch, and OpenCV. Now, what are these? Okay, TensorFlow, PyTorch, and OpenCV is. So just now we saw that there are different techniques, AI techniques, which can get integrated with robotics. What are those? Machine learning, maybe deep learning, reinforcement learning, computer vision, okay, computer vision and NLP. But to integrate each of these techniques, okay, we should have a platform through which, or we have to write the code, isn't it? Without writing it, we can't do it. We should have a platform through which these techniques can be integrated. Okay, so the major platform which can be used in integrating this AI into ROS nodes is it can be integrated through Python programming language. Okay, it can be integrated through Python programming language. So these TensorFlow. Hello.
ಏನೇನೋ ಕಾಲೇಜಲ್ಲಿ ಇದ್ದೆ ಹೇಳು.
Hello.
ಕಾಲೇಜಲ್ಲಿ ಇದ್ದೆ.
Hello.
Ma'am, you can continue. I have muted that
Okay.
participant. I think they have
Okay.
by mistake enabled the mic, I think.
Okay, fine. Yeah. So this integration, whatever it is there, right? So these integration, whatever we are doing, okay, it can be done, the techniques, whatever we told, isn't it? So naturally, we should have some platform through which those integration will happen. So through Python programming, okay, through our Python programming, and using these different, okay, packages, or I can say the libraries which are available in Python, we can make use of and integrate them. Okay, so the TensorFlow, okay, through using this TensorFlow and all, the deep learning models, whatever you have, okay, or I can tell it as the the machine learning models may be, the deep learning models may be, okay, those things can be integrated, all the different, and then through PyTorch also, you can integrate your reinforcement learning, NLP models and all, it can be integrated. And through OpenCV also, you can include different packages which are there in the libraries, and then you can integrate it. Okay, so that is how through TensorFlow, PyTorch and OpenCV, the different techniques of AI can be integrated. The models, different models can be built, okay, as an ROS2 nodes. So giving a proper flow of what it is. So as you know that in a robotic system, you have a camera node where actually the data is collected. Okay, so when the data is collected means, so please remember, we are talking in terms of a robotic system, means the data is, it can be any type of data, isn't it? So that that data through AI, it has to get it should be understanding that particular data, right? It has to understand that particular data, and it has to do certain decisions after understanding it. To do that, okay, you can make use of a perception node where you can integrate that perception can be achieved through this CNN model. Okay, and then once you get to know what is that particular data is all about, understand that particular data, naturally you have to plan accordingly what to do next. And then you can perform the action. Okay, so that is how the integration of AI is going to happen here. Okay, or I can tell specifically the AI perception node where it can be achieved, it can be achieved through something called as CNN model. So need not be that every time you have to go for CNN model itself. Okay, you can go for even for RNN model and so on, the other models also. But okay, just an example we have given where the AI perception node can be achieved through this CNN model. So this is how the AI integration can be done with ROS2. Next is how ROS2 and AI system workflow will be there. Okay, what is this is all about is how when we integrate AI with ROS2, okay, how the system will be functioning. That is what we are trying to show. Put it here. Now, to start off with, as such, it will be sensor data acquisition only. Okay, all the data has to get acquired. Okay, when I tell that it is sensor data acquisition, is it's not that it will be only through sensors. Yeah, of course, basically when it is a robotic system, everything is through sensors only. So through sensors, whatever may be the type of the data, it should get acquired. That is what it is. Because to build any AI model, right? To build any AI model, data is very, very necessary. So data has to get acquired. Okay, and that acquisition is happening through sensor. That is what we are trying to tell. And then next is perception and analysis. Okay, so the acquired data has to get to understand, and certain analysis has to be done. So to do that analysis only, AI is used. That analysis either it can be done through ML or it can be done through RL, or that is reinforcement learning, or it can be done through your computer vision, or it can be done through your NLP techniques. So any of the technique, or it can be done in a hybrid mode also, because it should be done in all the hybrid mode itself, because we have different types of data acquisitions may happen. So depending upon the data, the respective data gets analyzed, and then you have your decision making and planning. So naturally it has to be decided what to do after analysis. What is the next step to do? Whether to go forward, whether to go backward, whether to go right, whether to go left, or whether to lift hand of a robot system, or whether to drop an object. Certain decision has to be done, and it has to be planned properly. If it has to be dropped, how it has to be dropped, everything. That happens with respect to your control and actuation. The actions, whatever it is. Okay, so that after that, the continuous feedback loops will be coming. Okay, continuous feedback loop will be coming, such that the decisions can become very appropriate. So continuously data will be coming, continuous data acquisitions will happen in real time, analysis will be done on that acquired data, then it will be planned, and decisions will be happening and planned accordingly to do what to do for the actions, and that actions are controlled properly, and then feedback goes. So it will be a continuous process as and when the data gets acquired. Okay, so that is how we can tell that the system workflow when in ROS2, when AI integration is happening. Okay, yeah. Manju Prasad, can we take a break for some 10 minutes? Is it okay?
Yes, ma'am.
Yeah, so then we will take a break for 10 minutes and we'll resume back after 10 minutes.
Sure, ma'am. Okay.
Yeah. Fine. Thank you.
Thank you.
Yeah.
Okay. Participants, please stay connected. So hope uh, you have understood. Ma'am has clearly explained how AI can be integrated into the ROS. Ma'am has explained very nicely, and also she has also given a complete AI system workflow, how the data should, the captured data from the sensor will be analyzed, and then based on the analysis, how the actions will be taken, and again the feedback. So the complete AI, any AI based raw system, she has explained very nicely. So based on this, I just wanted to, like, since you already into the learning phase of ROS2, so you already familiar with the ROS2 core fundamentals. So related to that, I just wanted to give up some simple problem statement. So please try it out, because as I said in the previous sessions also, and the previous speakers also talk about it, you learn this domain only by doing it, are only through fixing the errors. So I just wanted to give up some simple problem statement. It is simply a subscriber and publisher node, but here we'll just mimicking the function of AI concept, since we have started with the AI touch today. It's our AI flavor. So I'll just put the statement in the chat box. So please try to implement it. Is that okay with all? If you stuck with any somewhere in the middle, I'll just let me know. I'll even though I don't have a like ROS2 installed in my laptop, it's there in the college, so I'll be able to guide you all. Shall I post it? Okay. So what you have to do is here. So you have to create two nodes. One is a publisher node. So you already know, Raghunathan sir already explained how to create a publisher node, how to create a subscriber node. So you have to create two nodes. One is a publisher node and one other one is a uh, subscriber node. Okay. So the node, whatever the node you create it as a subscriber node, that should subscribe to the LiDAR data or any sensor data. Since we don't have a LiDAR in real hardware, we don't have, we'll just to try to mimic that through the program itself. So we'll write that mimicking program or fake LiDAR data publishing program as a publisher node. So basically we'll be creating two nodes. One is a publisher node, another one is a subscriber node. And publisher node is something which is going to publish the LiDAR data. Okay, it's not a real LiDAR data, it's a fake data. So that node is responsible for publishing the LiDAR data. And another node, That means in another file, we'll write a program in order to subscribe that LiDAR data. So how do we publish, how the LiDAR publishes the data? There is a topic called scan. Through that topic only, it will publish it. Okay, so you'll be creating two nodes. One is a subscriber node and another one is a publisher node. So the subscriber node should be able to subscribe or should be able to receive the LiDAR data from the publisher node, and it should do some analysis. Here we are mimicking some AI logic, okay, to classify the obstacles, whatever the data sends data from the LiDAR. Okay, so based on the LiDAR, as ma'am told, first we'll take the data or will acquire the data from the sensors. After acquiring that data, then we're going to do the analysis by applying a simple AI logic. So here we'll write a simple program to classify the obstacles as near, medium or far. Because as we know that LiDAR is going to give a distance from obstacles to the bot or the thing. So based on that information, we're going to classify the obstacles as whether they are near to the system or medium or far. And these messages should be published. Hope I'm clear with the problem statement. You could please try it out. So you'll start with creating the workspace first. Hope, how do we create the workspace? Can anyone unmute and tell me how do we create the workspace in ROS2?
MKDR workspace. Man. You can create the command of MKDIR. Make that.
Yeah, MKDR. So, so create the workspace. So inside the workspace, please create the package. Yeah, inside the workspace, create the package. And message type is, please mention the message type as std_messages. After RCL pi. So here the message type, you should mention it as a std_messages, or else I can share the code as well. First try it, otherwise I'll share the code. Then you just try to do it in your system and observe the output. Copy from the recent chat, because I think that's split. That is all the information.
Oh, hello. Arpitama, can we start?
Yes, ma'am.
Okay,
Can
yeah,
start.
fine. Thank you. Fine. Okay, so welcome back. So I think this is where we stopped in getting to know in the entire ROS 2 workflow, if we integrate AI, how it is there. So this is just again a uh, the diagrammatic way of showing the integration of AI. Okay, so we all know that ROS means like it has got the service, the abstract layer, I mean the middle layer, the application layer, and the OS layer as such. So where and all AI comes. So as we know that basically, as I told, as we were telling that the major integration of AI will be with respect to node, isn't it? The nodes. So where their main job will be with respect to perception, because there are the nodes where your application individual application will be running, isn't it? So that is being done through perception. So you have to understand your data and everything. So that is, to do that only, yeah, you have your AI vision, the NLP, the sensor fusion and all should happen, because you have different types of sensors which acquires different types of data. Ultimately, the data acquisition will be happening through sensors itself, isn't it? But different sensors will acquire different types of data, where that fusion of data should happen. So that is what has been achieved through your AI. And then the next is the services, whatever it provides, isn't it? The services is like you have to plan it. So the planning is the next one. What to do? The after acquiring the data, and then drawing certain insights out of the data and getting to know what it has to, how the data is and everything. Ultimately, it has to be planned, and a specific decision has to be done. Okay, you have to do certain decisions there, depending upon the data, whatever you have got it. And then it has to be planned properly, where to do what and all. Okay, and that is being done again through some controlling systems. Okay, some, because ultimately it is a robotic system, isn't it? It is a robot. It is actually a machine where it has to move the arm, means naturally for that movement some actuators are there which helps in moving that particular arm of a robot. So that is actually controlled by again a motor. So that is how in every step of the robotic system, okay, the AI integration is happening. So basically the AI integration will happen at the top level itself through the perception layer, what we call it as, or the top application layer, whatever we saw. That is where it is going to happen, where the AI plays a very important role in getting to know about the data, what type of data it is, how it is, and finally helps in decision making. Okay, so this is a diagrammatic, I can tell, view of integration of AI with ROS2. Next is in each component wise. Okay, in each component wise, how AI integration can be done and what is its purpose, that we are trying to get to know. Okay, so we all so in the first column, as you see, we have this AI function. Okay, AI function. And then in the second column, if you see, you have the ROS2 components, because we have different components there in ROS2. And then we are getting to know what is this the purpose of your that thing, the AI input. Okay, so now let us see that, as we know that AI function is for what is this? The sensor input. So that plays a role in ROS component. It is the sensor nodes. The purpose is like publish camera, LIDAR, IMU data. That are, all those things are the the sensor data only, isn't it? So through which the acquisition of the data is going to happen, and then data processing should happen, because once the data is there, you have to process it. So that is in ROS2 component, that is achieved through your processing nodes. Okay, so you have to filter and pre-process the sensor data and all. Pre-processing is, that is what I told, right? So the unwanted data should be removed, and then the outliers maybe, or the noise maybe, all those things, or the missing values, whatever it is, unwanted data, all those things has to be removed. Sometimes the picture, whatever it is captured, okay, because when a robot is viewing, means whenever it is viewing in an object, means it is viewed as an image. Okay, that because of the camera, of course. However, because of so many hardware fail, I can't tell, is hardware malfunctioning. Because of hardware malfunctioning, the camera may not be so, the camera picture, whatever it might have captured, the image may not be very maybe of high resolution. It might have blurred. Okay, or half an image might have taken. So it has to pre-process for the robotic to understand that type of data also. So that is how, what we call it as pre-processing of that particular data. All those should happen, everything very faster. Okay, so some of the data, unwanted data, has to be removed, everything. Okay, so that is entirely is being done through your pre-processing of that particular data, and that is happening through your in the processing node, and that is again helped through AI itself for doing the filtering, the pre-processing, and everything it is being done. Then the next is your perception, right? The next is your perception, where AI, it is being done through AI perception nodes. So where actually you detect the object. Okay, the purpose of that is AI perception node, we call it. It is being called as, where actually the object detection, the recognition, and everything will be done. Okay, next is localization and mapping. Okay, where it is basically done through something called as SLAM nodes, where the SLAM stands for simultaneous localization and mapping, where it has to position properly and it has to map properly. Okay, so this has been done through specific nodes or some packages which is in ROS, which helps, okay, which helps in doing this. Okay, like for example, an arm has to be moved through a 90-degree, means, okay, that proper positioning of that arm, okay, to 90-degree has to be done, and properly it has to be mapped. So there are many built-in packages or built-in software, specific softwares which are available in this SLAM nodes, which actually helps you in proper positioning and mapping of that particular data in a proper manner. That is being done through your SLAM nodes, which is again one of the component in your what I can say ROS2. Then finally, once all those things is being done, you have to do the decision making, right? So in decision making is being done again in the planning nodes. The main purpose of this particular planning nodes is for path planning, to do action selection, what to do, whether to move ahead or to block or to, okay, to stop. So once the decision is taken, next is the action to be done. Okay, to do that, this plan that is being done through your what is called as planning nodes. And then the AI function is for learning. You have something called as learning nodes, where the model gets trained, it gets adapted, Okay, it gets adapted to the environment. Okay, contextual context. Okay, it has to get dynamic change in the environment. Also, it has to get adapted to. So only that adaptability to the change in the environment plays a very important role in the modern robotics. Then naturally, and next is the communication. Okay, because communication is, we call it as an AI function here, is why? Because once the data is acquired, okay, it has to be moved for analysis. So naturally, the acquisition of the data is done through your communication. Okay, that acquisition is done through the communication. The movement of the data, the transfer of the data is through different protocols, or through different services, whatever you have, that is being taken care basically through your DDS based data exchanges. And then the controlling will have, you have to have, that is being done through the control nodes, where actually it generates the commands for the motor to do that specified action which is being generated through AI. Okay, AI is the one which helps in decision making, whether, like for example, there is a ball which it has to pick up, means the robotic arm. Okay, AI gives the decision to pick, that's all. But it is through actuators only the ball gets picked up. That is what is, to pick up that, there should give the system should give a command. Got it? That is what is the control node does, where through it generates certain commands for the actuator to pick that particular ball. Okay, so it is not, AI plays a role in giving the decisions, but through actuators and what we call it as this control nodes, what we call it as these control nodes, that particular decision comes into action. Okay, and of course, another important thing in any of the robotic system is the security. Okay, that is achieved in ROS through something called, through what is called as DDS security layer. Okay, where, because entire workflow or the entire system, the robotic system, is entirely dealt with data. Okay, so having a proper, correct security for giving proper and correct security for that particular data is very, very important. Okay, so that is achieved through what is called as this DDS security layer. So where the main purpose of it is for authentication and encryption. Okay, means that data or any, because ultimately it is a robot system, it is a machine, anybody can operate, but it should not lead to some other thing, isn't it? So a proper way of using it also should be taken care. So all that thing, the data or the functionality of that should be authenticated properly. And of course, the other thing is the scalability. So scalability is that it has to do multi-node system. Okay, multi-robot coordination has to happen, where two or more robots has to communicate among each other, such that a huge task can be done. Okay, so this is how, in a layer wise, in ROS, where and all AI can be integrated. So this is just another view of telling in an entire ROS2 workflow how AI can be integrated. Okay, then next is, what are the application of ROS and AI? With the integration of AI, okay, with the integration of AI, right? What are the different applications where it can be used? Is one of the major application will be here in autonomous vehicles and drones. Okay, so nowadays everywhere, especially in abroad or outside India, autonomous vehicles are coming up. You know Tesla has come up with an autonomous level 2. I think it has come up with level 3 autonomous vehicle. Okay. When we tell autonomous vehicle, there are different levels also. So each has got its own autonomous, I can say, criteria involved in it. So in that there, one of the application will be with respect to ROS2 and AI integration together, and of course with industrial and collaborative robots in industry and in healthcare and in service robots. ROS2 and AI have been can be used of, and of course in agriculture and smart farming robots in agriculture it can be used, and of course and space and defense robotics. So these are some of the applications. Okay, some of the applications where ROS2 integrated with AI can come in can be a very useful one. Next is, what are the advantage you have when this is being done? Okay, without AI, we got to know what are the major limitation it has, but with the with the integration of AI onto this ROS2, what are the advantages it has? One is it is modular, and it can have modular and flexible architecture. Okay, now what do we mean by this? Okay, what do we mean by telling modular and flexible architecture means that with the integration of AI, the ROS2, whatever it is, it can follow or it can function and run independently. Okay, in the sense, what do we mean by telling that it runs independently is no human intervention will be there. Okay, human intervention will not be there at all. So everything will be autonomous. Okay, everything machine only can take care. That is what we mean by telling function independently. And since different AI components are integrated, okay, can be easily integrated without replacing or without affecting the entire system, only because the AI integration is going to happen at the top level itself. Okay, since it is going to happen at the top level itself, the other systems will not get affected because of it. That is what is one of the advantage here is. And then it encourages reusability and scalability. Okay, of course it can be scaled up to huger systems, and the same robot can be used for multiple different purposes. That is what we mean by telling it is modular and has flexible architecture. The architecture, once it is designed properly with the integration, it can be used for multiple different uses, different robotic platforms it can be used, and it supports multiple sensor integrations and different hardware configurations. So that is what actually we mean by telling modular and flexible architecture. And then coming to next point is enhanced autonomy and intelligence. Now, what do we mean by this? Enhanced autonomy and intelligence means since the AI is integrated, okay, since AI is integrated, all the decisions are autonomous, okay, which helps in perceiving the data properly and learn on its own, because that is what AI is all about, where the machine learns on its own. And since it is integrated with AI, deep learning is one of the technique which can be included, where using that deep learning technique, it improves in detecting the objects very well. Okay, because it should not detect the objects wrongly. Okay, if an obstacle is there, it should get to know that it is an obstacle, wherein it should stop whenever that obstacle comes. So, but to stop, first of all, it should detect that particular object and analyze, come to the decision stating that it is an obstacle. This is being achieved through AI in a greater manner, and understanding the scene around it. Now, like what I mean by telling is understanding the environment around it. Okay, that is achieved through the integration of AI. And then through another technique of AI, which is reinforcement learning. Okay, that helps in adapting to the environment, unknown environment, in a rapid way. Okay, so as we told when we saw what are the different techniques, wherein AI can be integrated, is one of the techniques is reinforcement learning. Through reinforcement learning, what it can be done is that it supports, I can say, different behaviors, such that for any unknown environment also, quickly it gets adjusted. See, normally robots, when you tell, they do only monotonous job. Okay, picking the object, go there and keep. Picking the object, go there and keep. So that they keep on doing it. If that is the monotonous job, whatever they do, suddenly if they are being shifted to another environment, means depending upon that environment, it has to get adapted to that new environment, because it is being done doing the same task for many days, you think. Okay, the monotonous environment only it is being adapted, but suddenly if you change it through this reinforcement learning, okay, adjusting to that unknown environment can be achieved by that particular robot in a very, very soon. It can do that. Okay, and then autonomy and intelligence is achieved, okay, where there will be minimal human intervention. Okay, means you are making a human intelligent. Okay, so that is what it is. So AI enhances the intelligence. That is what I can tell. Okay, but we are not telling that it replaces the human intelligence. Okay, it enhances the intelligence. That's all. Okay, so and then coming to the third point is real-time and safety critical support. Yes, of course, since the ROS2, whatever we have, okay, it supports real-time communication. Okay, so and it is deterministic execution it is. Okay, and all your quality QoS policies and whatever it is there, it ensures that the message delivered properly within a specific timing constraints also. So this is what is the major advantage of ROS. But with the integration of AI, okay, it improves this operations, whatever it has to do, in a very, very proper manner, and it improves systems predictability, or it improves systems performance in a better manner. That is what it is there, which is very much necessary for any of the safety and critical support systems, like autonomous vehicles maybe, because their safety is also important, and immediate decisions has to be taken. And if any of the robots are involved in any of the medical systems, there also it is very, very critical, where quick actions has to be undergone. And of course, in any of the industrial applications, if any of the robots are involved, so these things, integration of AI with ROS will help in a very better manner. And of course, the deployment and the faster prototyping and deployment can be done. Why? Because the ROS2 has got got high packages, pre-built very high packages. With the integration of AI, means it has got many different I can say libraries which are involved. Okay, different libraries which are involved, which helps in deployment of those robotic systems in any of the applications as well. So this is what is the major advantage of I can say ROS with AI. Next, let us try to understand what are the challenges and research issues which may come up whenever we are trying to integrate AI with ROS. The first is high computational requirement, of course, because all AI models, especially when you talk about these deep neural networks, deep learning models, what we told as the CNN and RNNs, no, they require huge processing power. They want very high computational equipments in order to train the data, in order to generate certain insights out of it. So that is what is the major challenge comes into picture with the involvement of AI. And then since it has to do with all these can be done with the help of with the GPUs or GPUs itself, that is very, very necessary. But the major challenge comes into picture when there are these resource constraints are there, where the systems are not capable of going for this high computational systems, then it becomes very, very difficult. But that can be done with the mobile robots as such. But with the resource constraint, achieving high accuracy is again a challenging one, because the latency issues may come up. Okay, then the energy consumption may come up. Okay, so but how effectively it can be achieved is again a challenging one. Okay, next is real-time AI inference constraint. Okay, what is this real-time AI inference constraint is? Because through AI you can infer certain things, but for that inference, okay, there is a need for it introduces something called as latency and jitter. Okay, why? Because immediately it has to infer certain things. That inference may, if it is get delayed by few things, again the decisions may not be proper. Okay, so this is again a challenging one. How fast the inferences are achieved? Okay, how fast the inferences are achieved, which in turn affects the control loop, isn't it? Because if you don't give within a specific time for a robotic arm to lift the bottle means, okay, the entire system may become a chaos there. Because of which interconnected also gets affected, because of which the interconnected also which gets affected. So the inference, the latency should be so fast. I mean, the decisions should be coming with so fast that it does the actions very, very quickly. Okay, that is what is the inference constraints are. And then the real-time ROS, whatever we have, okay, these nodes, they require QoS and scheduling properly to be done. Okay, so that, okay, all the nodes and the services, whatever they are, isn't it? All the nodes and the services, whatever it is, everything is being done properly, correctly, such that the entire system, the entire system will be achieved in a proper manner. So the main research focus in this particular thing will be how well a lightweight model can be developed such that this latency and the jitter can be reduced. That is again a research and a challenging issue here. Now, coming to data security and privacy concern. Yes, we know that the robots, whenever they are there, they collect very, very sensitive information, like it may be images, the locations, okay, everything are there. And most of the when we have a multi robotic communication is happening, that communication happens through a network itself, where they are prone for attack and data breaches may happen, because the communication itself, we ourselves, we know that nowadays so many communication through cyber attacks and all are happening, or isn't it? So, but whereas these are the machines, ultimately they are machines. Okay, so whenever the data communication is happening between the networking thing, data breaches may happen, and they are prone to these cyber attacks. Cyber attacks. So securing that particular transmission of the data and the storage and access control is a critical challenge here. So only the data security and privacy concern is one of the thing what we have. And then the another thing is how well privacy preserving AI and secure ROS communication can be achieved is a active research. So in these areas, some researchers, whoever are interested, can take it up. Okay, how privacy preserving can be done with respect to AI, and secure ROS communication, how it can be done. Okay, that is one of the area which anybody is interested in taking up a research work can take it up in these areas also. And okay, that is what is the thing is with respect to data security and privacy concern. And then faster prototyping and deployment. So naturally, whatever the major challenging is how quick enough the prototype can be developed and it can be deployed such that it can whatever the task it has been assigned for, how best it can achieve that particular task. Okay, so irrespective of whatever may be the I can say advantages of integrating AI with ROS is there, but still these are some of the few challenges which come across, okay, in actually integrating them. Okay, like it requires high computational requirements because the data is so huge. It has to process so quickly. So that is what becomes one of the major challenge, and the inference constraint may be, and of course the data security as such. So to conclude, I can tell that ROS provides a very robust and robotic backbone is there, and through AI integration, it enables the intelligent perception and learning. Okay, so this combined technology will be the next gen robotics, because it takes care of everything from what we call it as end-to-end system as such, and then because of which it has got a significant impact on industry and research as such. So this is what is the overall conclusion of my session here. So now I'm going to stop. Next, I'll be showing some simulation, hands-on simulation of ROS with some services and everything. But before going to that, any questions you have, I can take it up, or else I'll directly jump to my programming part.
There are two questions in the chat, ma'am.
Yeah. Yes. Yes, ma'am.
One from Ravi Kumar, sir. DL algorithms have perception built in, ma'am.
Yes.
That was the question, ma'am.
Okay. DL algorithm perception built in the sense, see, DL algorithms, when we say perception, you have to feed in the data to it, okay, so that they can learn on their own. So, but you have to train those data also, isn't it? So the major thing is you have to give the data to any of the algorithms as such. That is what I can tell. Hope I answered. Next question, ma'am.
AI and ML are same aspects.
AI ML, I can't tell it as AI ML as same aspects as such. if you want to deep dive into AI, we have so many other things associated with AI, something called as agents, reflex agents. They have to acquire, okay? They have to get to know about the environment and all. There, AI plays a role. How they get to know about the environment is what AI deals with. But ML is an inner circle in AI, deep little bit inner circle with AI. Like as I showed, let me go back if that is the case. Uh, yeah, AI is like any of the sensors or any of the system. We have something called as PAS thing, which any system should know about it. Okay, knowing that, we have to process that particular data. Okay, that processing of the data or building the model, everything is dealt with AI. I mean ML. Okay, the decision making with respect to the type of data it takes, that is being taken care by ML. AI is for acquiring the data, getting to know about the environment, from where the data is, through sensors and all. AI plays a role there in getting, through agents. Okay, we get that particular data, take the data, and that taking that data, how do the analysis part is going to happen on that particular data is taken care by ML. So inside that we have DL. Why we have inside this DL is basically DL will be deep driving inside with respect to the data for the depending upon the type of the data. Okay, this is architecture based. To tell you frankly, all three are data driven itself, without which they can't perform anything. But depending upon the type of the data, okay, each one is considered. Okay, if you have a data entirely related to structured oriented, you can do those with respect to using machine learning. If you have a data where it has unstructured data, wherein you have to take certain decisions on that, you can go for deep learning. Then, now where this AI comes into picture is, like if you have to take a specific path, like for example, a tic-tac-toe game you have. Okay, it is a squared game where X and O will be there. So where to place next X, which path it has to take among the given path. To that decision, AI plays in. Through AI, different algorithms, maybe like we have something called as A-star algorithm, okay, which helps it in deciding which path to go. Okay, that is where AI comes into picture. AI algorithms, rather, I can tell that they come into picture. Yeah, any other questions, ma'am? Any other questions? Hello? No more questions?
Excuse me, ma'am.
Yeah.
Ma'am, can we suggest any current ongoing research in related to the DDS, like data security or privacy, in the reference of industrial robots or other platforms which is related to the robotics?
Sir, the research, you want to take it up or what it is? Like any research challenges or what you want, sir?
Go for the challenges or issues of the securities, data security, or related to the privacy, then definitely we want to be interested to current status of the ongoing research.
See, when you talk about the security issues of the data, okay, the major thing is lies with three things, well, two things: authentication and authorization, isn't it? So you should be dealing with those two basically. Okay, how well you who is the person who is authenticating and who is authorizing to use that particular data? That is the thing you have to deal with. Okay, and when you talk in terms of DDS, okay, basically it is a distributed data. Okay, it is a distributed data. So when it is a data is distributed on different nodes, okay, the security lies in each of the nodes also. So in each of the node, how well the data is secured, how well the data is authenticated and authorized, that has to be checked up. That is what is the major challenging when you talk in terms of security and privacy. Okay, so that
Well,
is where you can take it out.
Ma'am, can we just seems to look up in reference of the loggings of the data, or we can say that the perceptions, whatever the readout by the robot, by the sensors and other devices, or
Sir,
field inputs?
no, sir, I don't think so. See, however, only through logins, I can tell that your data is secured, isn't it? How you are storing the data also matters, right? Because the security breaches will happen because of that only. How well you are storing that particular data also matters much. In what way you are storing the data?
Ma'am, can we just work for two data log files, like we are just preparing the whatever the moves by the robots on the basis of perception they are doing, and on the basis of that, whatever the logs they are preparing, how there we can work for the security to avoid the attacks by using that logs and other things?
Yeah, that is one way of securing the data. See, logs is, see, for example, logs will be can be generated every second of robotic movement, isn't it? So naturally, suppose a robot moves from point A to point B, maybe a distance of 5 meters also means the entire log gets generated. So only on the basis of that log, you can't tell what will be the further action of robo, what it is doing, isn't it?
Right.
Okay, yeah. So that is not the. According to me, according to my perspective, I may be wrong also from your perspective, but my perspective, that may not be the only way of securing the data, because we can't decide upon what happens next action, what that particular robo is taking. We can't come to the conclusion, isn't it? So only through log, I don't think so you can do anything with respect to the security, sir, because ultimately somewhere the data has to be stored. How secure the data gets stored, if you attack that, I think it will be a very good research work from my perspective, sir.
Okay, ma'am. Ma'am, one more thing that you
Yes,
have
sir.
mentioned, there is in a slide, there is a AI inference. We are just adding with the in a context of to getting the perception for the movement, or by using the plugins like SLAM, etc.
Yeah.
So can you just, ma'am, give me the sort of examples to where we are exactly putting the inference, or what type of inference we are integrating there in
Okay.
service or action level?
Yeah, let me just give you a small workflow only. Let me tell. Like, think that I have a robot. Okay, it captured the data of an image. Okay, so first it capture through lidar or through camera, the data is captured. Then the AI intervention comes there in identifying that particular image. Okay, once it is
Correct.
identified, correct? So once it gets
Yes.
identified, next will be the decision to tell what type of an image it is, whether it is okay. First after that image, it has to classify what type of an image it is, whether it is a human, suppose, or an animal. Just I'm giving an example. Okay, I'm just giving an example. So to do that identification and classification also, AI comes into picture.
Ma'am,
Correct?
that means at that moment of point, we are talking about the knowledge type of data set for the as a inference.
Inference, the inference will be next is what after classification the inference comes. Suppose it is a human, the inference is human there. The inference comes there.
On the basis of supervisor, we can say that.
Yes, on the basis of the data, whatever it has captured only. No, the
Yeah, that data
perceived
can be considered as a supervisor.
yes, that's it. The simple example I'm giving, but it is actually a complex data comes into picture. I'm just giving my perspective in a simple manner. That's all.
No,
Okay,
ma'am,
that
I
is
just seen your slides. You have mapped very clearly with the AI and robotics. That's why I'm get the points how we get just doing the things.
yeah.
So that's why I asked. Thank you.
Yeah,
Thank you for that
yeah.
slide actually.
Yeah. Okay. Thank you, sir. Yeah. Anything else? Any other questions, please?
Hello.
Yes, sir.
Good evening, ma'am.
Yes, sir. Good evening, sir.
Ma'am, I have one question. When we have to introduce AI in robotics, robot during the programming, or we have to need some extra programming for AI?
Sir, it will be in the node level itself. You can introduce AI, sir. Whenever at the node level, because each ROS when you have, it will be at the application layer where each node is an independent programming you can do for each of the thing. From once the data acquisition gets, from there only the entire AI can be introduced fully.
So, ma'am, we have to update our AI program every time, or once we have to done that program?
That is where the scalability comes into picture.
So means we have to define in a week manner or month manner or year manner.
Not that way. Need not be. Change in the technology, naturally the changes the platform on which the I can say the algorithm changes.
Okay. Thank you.
Okay, that is where the interoperability, what we call it as, dynamically the change, that also it should get adapted, means that it will be entirely with respect to the change in the environment, change in the technology.
So ma'am, for this we have to introduce any program in our robot?
No, sir. Yes. For functioning of that particular robot, that will be done through this programming itself. Yes.
Okay.
You have to introduce it.
Okay.
Good evening, ma'am.
Yes, sir.
My name is Kiran, ma'am. I'm pursuing
Yes, sir.
MTech in robotics and AI, ma'am. So,
Yes, sir.
actually, I'm doing project on autonomous grass cutting, ma'am. So, in my mini project, I have done with the semi-autonomous, which you can control through Bluetooth. So,
Sir, your voice is not so clearly audible, sir.
Actually, my goal is to reduce the cost of building, ma'am.
Okay.
So for that, so I have built my robot fully designed. I have started implementing, added the plugins of sensors in ROS2. So now, where I can use AI in that?
At the node level itself.
Suggest.
Sir, you can use it at the node level itself. See, grass cutting, okay, as a problem statement with respect to the grass cutting, okay. So you'll be capturing the images of grass as your robo moves, okay. Real time, the capturing of the grass should happen, isn't it?
Yes.
Then, yeah, there itself at the node level itself, you have to introduce an AI program first to identify whether it is a grass or a weed and classify it. There
Okay.
only it has to come. There only it has to come. Once it comes to the detection, identifying of whether it is a grass, then your arm should cut it. That is the action part. So the AI part will be for identification and classification, because when you have your your problem as automatic grass cutting, first and the foremost thing is your robot should identify whether it is a grass or something else. So to identify and detect, you can use your AI part, AI there, your CNN there. Actually, to tell very specific, you can go for your CNN.
Will it cost, ma'am? Will it be more costly?
Sir, I didn't get your question, sir. Pardon me, sir. Please repeat it.
Ma'am, means the computational cost will be higher, right?
No, sir. You can
Yeah.
deploy. Yeah, because see, if you want to train it on a very huge images, you can go for a GPU as GPU. You can take it up, or a minimal size if it is there. You can work it on a GPU for identification and classification. If it is more, then you have to go for high-end systems. But minimally, it is there means you can train it on a smaller GPU itself, on a minimal hardware part of Jetson Nano only you can train it off.
Okay. Actually, I'm planning for the Raspberry Pi, which is 8 GB RAM.
No,
will
sir.
it be sufficient?
Raspberry Pi, large scale images with Raspberry Pi 4, I think you can have too much of GB there. But if you want to achieve a very good accuracy or something, you can go for Jetson Nano.
Okay. Okay, ma'am.
Yes, sir.
Yeah. Yes, ma'am. And what about in the navigation, ma'am? Will it be useful?
Navigation for that is on the action part, no. So there only the localization and mapping comes into picture, no.
Yeah, SLAM.
Okay. There again the AI integration can be done for identifying the path.
Okay. Okay, ma'am. Yeah.
Yeah.
Thank you, ma'am. Thank you so much.
Yes.
It was very informative session. Thank
Yes.
you.
Yes, sir. Thank you, sir. Okay.
Ma'am, do you suggest any internships can be taken on OpenCV on this? Will it be required?
Open. Sir, you can mail me, sir. My mail ID is with Manju Prasad, sir. You can contact him and drop me a mail so that I can suggest. Right now, I am not getting anything, but surely I can help you out in that.
Sure, ma'am. Okay, ma'am. Thank you.
Yeah.
Thank you, ma'am.
Yes,
Thank
sir.
you.
Yes, sir. Yes, sir. Yeah. Any other questions, or shall we move to a simulation?
Yes, ma'am.
Yeah. Sure. Okay. So here we are just simulating certain robo activities through Python code. Okay, where actual robo implementation we have not done. So the simulation, how it can be shown through simulation, we have done certain programming here. So this programming, again, we have done it using Python and its different libraries here. One of the this particular simulation is you have a publisher node and a subscriber node. Publisher will be publishing the data, some random data through certain message, and subscriber will be listening to that particular data. Okay, so here these are some of the packages which have been implemented. So this is a simple publisher node through a function. It is being done where randomly certain data gets generated. It has been named as sensor data, and that publisher node will be keep on publishing a message of taking this particular random data and publishing it with a count and topic of the messages it is publishing. Then is the subscriber node. This is the subscriber node, wherein that particular subscriber will be receiving that particular data, whatever the publisher is publishing. So this is a simple robotic, one of the simple simulation, this particular program we have done. Okay, so for running that, we have used different package, and it has been simulated here. So let me run this particular program.
Ma'am,
Yes, sir.
is it on a Windows platform? This one, what you are showing?
This is in Colab, sir, using anything. It is Google Colab, na? Jupyter Notebook.
Okay, but on Windows platform.
Anything. Yes, Windows. Okay. So this is what, like, the publisher has started and the sensor data is captured, and from the subscriber, it is telling that I heard. So it keeps on receiving and taking the data. So this is just a simulation, one simulation we have done at this one. Then we have this another simulation, again the same thing, but it is through identification of certain obstacle and how the publisher and subscriber node will communicate in identifying what I can call it as a obstacle here. So that is being shown in a visual format. Okay, because the simulation means we have to show that in a visual format. No, so for that, these are the different, I can say, Python libraries. It has been imported, and that is being showed in a visual manner as well as in an animated way. Okay, so like NumPy and Matplotlib, Matplot, PyPlot, all those are explicitly for visualization and animations thing. So that is what it is being showed here. So just this is another program, the simulated one of exactly the robotic, how it will move, that can be done instead of fully in a hardware robo. You can even do that in a simulated way also. That is what we have shown here. Hope so my net will work here, because since it is in Colab, yeah, this is what is the simulation way. So if I start, if you just, okay, let me start. It is going a little bit fast. Let me show. If you observe, it is telling that obstacle identified. It is moving. Okay.
Yes, ma'am, it is visible.
Yeah, this is one obstacle one. Okay, so this is one of the simulated when rather, okay, that is what is the what I can say, the usefulness of your simulation here again. So everything we have done it through a simple way of doing the simulation here than in a fully, okay, I can tell in a hardware part as such. Okay, then this is another simulation again using CV thing package, where it is simulating AI detecting a ball and calculating the steering error as such. So this is another thing. Let me just run it. Okay, so it is detecting steering error. Okay, this is one thing. Then this is again another simulation we have shown, like what is the goal, because just now I told about the tic-tac-toe game or the movement of the path and all, right? So here this is another simulation where it detects the goal here. So if I simulate here, the ball is moving and it will reach the goal there. Yeah, that is what it is. This is a robo which is moving the goal. So it is crossing the obstacle also and then coming and moving it. This is another kind of a simulation, a small simulation we are showing here. Instead of going for any of the hardware, these kinds of simulations also can be done again with many other way also. This is one thing. Okay, then this is another program we have done for a circular room with a few pillar obstacles. Okay. There's an obstacle, it is stopping there, it is not moving. Okay, with a circular manner, which is going in a circular manner. That's all. Okay. So here, see this again, the LIDAR, the data has to be taken and everything. The random data is taken, everything is done. Okay. And then for simulating, again, these packages have been imported in Python, because that is what is the basic, I can tell, a major advantage of having the Python here, where it has got for any of the simulations maybe, or I can tell it as for any of the model building of any AI, I can say programming you have to do. For everything, it has got built-in packages. It can be done. And if you have any of the resource constraints also in executing that particular technique, because entirely it is dependent on the data, especially when you're dealing with images. The data is very large, and especially the normal systems may not be capable enough in storing such huge data. So the advantage is that you can go for your Google Colab, okay, where they give certain GPUs maybe for training and training the data and building all these kinds of codes. Okay, so that is how the resource constraints, whatever will be there with our systems, that can also overcome. But still, Colab also has got certain I can say limitations, where more than specified GPU, it can't give you the access. So then there will be a need for you to go for any of the high-end servers within your organizations maybe, or so on and so forth. But until then, Colab is the one wherein you have that flexibility in processing such huge voluminous data also. Okay, so this is just a simulating environment we have done, wherein okay, a simulating environment we have done of the same robotic thing without a hardware, through simulation which can be done. Okay, so that is what is all about for my session. Up from the questions, whatever we have, you have any other questions, I can take it up, or else I think that will be the end of my session.
Ma'am,
Yes, sir.
to bring the ROS environment in the Windows platform, can you send any SOP PDF so that because we were using with the Linux only, but if we want to go the Windows on Windows, actually, I don't find any that much of things. Do you have any particular portal or any SOP PDF?
Sir, I can mail you, sir. If you send your mail ID or something to me, I can just mail you and give it to you. Give it to
Thank
you,
you.
sir.
Thank you.
Yes.
Ma'am, this code can be implemented in ROS2 indirectly, or any changes are required?
Sir, you require ROS2 directly on the node level. You can do it, sir, if that is the case. Because if irrespective of you doing in Linux platform the ROS, the entire code is Python, no?
Yes, ma'am.
Okay,
Yes.
and this has been done in the DDS middleware itself, because it's in the node itself, isn't it? Okay, and this is a Python code. So even in the Linux environment, you can run this Python code, no? In ROS2, this is actually comes in the middleware, in the DDS middleware, where it is a node, wherein you can run it. Because it's only that is what is the advantage of you having the Python as a platform or a programming language wherein we can do the simulations and all.
Yes, ma'am.
Yes,
for
sir.
my autonomous graph cutter, or for the
Yeah, you can
mapping.
do. You can do.
Yeah.
You can do. Yeah, you can implement it on directly on your middleware. On directly, you can implement on your system, and then you can directly move that onto your any of your what is that the edge device, whatever you are using, whichever the edge device you are using for hardware part. No, you can deploy that onto that. No, you can
Yes.
do. You can do it.
Okay, ma'am. Yeah, got it.
Yeah.
Ma'am, some participants are asking this Jupyter notebook.
Yes, Manju Prasad, I'll share you. I think you can share them. No problem.
Participants, once collecting the notebook, will be sharing, and maybe if anyone have not had any hands-on the Google Colab, maybe tomorrow one session we'll just show how to load the notebook program, what madam is going to show, save in your, means you can just upload to your Google Drive or Google Colab, and you can run it on your device like laptop, mobile, whichever the operating system you are using on that device. It's just a browser based. You can directly just Google, like Google Colab, upload this particular document, and you can run. So if required, based on your request, after getting the program from madam, so we'll just show the demo of that particular thing. So you can just practice this simulation. If in the initial day also, like someone asking like they don't have laptop, they're using mobile, whether anything can be done in mobile. So participants in such a particular situation, so you can just try this simulation and get an idea about ROS and implementing AI along with the Python code and all. Any other questions from the participants?
Excuse me, sir.
Yes, sir. Please go ahead, sir.
Tomorrow we'll be having what is called this examination also, no? Test, sir?
Yes, sir. Test also is there. This Colab is hardly, it may take on 5 minutes. So some if required, based on the participant, we'll just put a poll. Based on the participant request, so we'll just try to share this particular thing, because this is a platform independent, and even you can do various simulation with this with the Python packages what madam has shared. So it may be helpful for some of your simulation if you don't have ROS environment.
Ma'am?
Yes, sir.
Ma'am, what are your current research, ma'am? What are you doing currently?
My current research is again on AI itself and its application in different domains, sir. One is on healthcare. One of my research scholar is into healthcare. So that it is. And then another thing is on, especially on cloud computing thing, how AI can be integrated in cloud computing with respect to the interoperability issues of cloud deployment. That is what is currently I'm doing. And then, of course, on different AI techniques, whatever I showed, I'll be giving small some projects related to that onto my students on different applications, especially on RAG, because nowadays LLMs are taking over. So what are the major lacunas, what LLM has, how to mitigate that? That is what we are trying to concentrate on.
Can you explain on that, ma'am? What is that track?
It's
short.
a retrieval augmentation thing, sir. Like, see, what happens is that comes majorly with respect to LLMs. LLMs, I hope you know that they are large language models. Okay, like,
Yes, ma'am.
okay, openly I can tell it is. I think nowadays most of us are using our ChatGPTs, Gemini, and Copilots, and DeepSeek, and all. So the major architecture, that is what we call it as LLMs, where internally they do it on your DL itself. So when you have this LLMs, isn't it? And the input, whatever you give is, you are giving it through your prompts. So the prompts are taken, and then the data gets retrieved. Okay, indexing will happen, and the data gets augmented. Okay, retrieval, augmenting, and generating the data. So that is what is RAG is all about. So the prompts, whatever you give, isn't it, that should get retrieved. So that R stands for. Okay, indexing, it has to put it in a proper manner. All the data should get augmented, and finally you'll be getting a result. Okay, that is what is the RAG pipeline, what we call it as. Why basically RAG we are looking at to is, most of the LLMs hallucinate. Means hallucinate is that they may not be understanding what the result should be given. So the same type of data will get generated often. That is what we call it as hallucination. How do we stop that hallucination, or what are the reasons in hallucinating, the hallucination for LLMs? That is what we are trying to understand. That is what is RAG is all about, and hallucination, LLMs.
Yeah, got
Because
it.
yeah, because any of the, now you take any application, everywhere chatbots are come. How do we develop? And chatbots are, again, depending upon the question, whatever you have given, there are two ways how the chatbot works. The question, whatever you give for a chatbot, they can go search within the servers, whatever they have, within the database, whatever they have, and retrieve and give you. Or again, the chatbot can search from the web. So two ways you can get the result. So, but in what way they are doing, that you don't know. That is where the transparency is not there for any of the AI system. That is what I was talking about.
Like this perplexity is searching on the current website, right, ma'am? You said
See,
second.
perplexity is also an LLM, sir. Even your chat GPT also will search the web. Your Gemini also will search the web from different sources. And even your Copilot also will search from different sources. Perplexity also will search from the different sources itself. That is where it gets augmented, and then the results will be given to you. But again, those LLMs, another drawback of those LLMs are reliability. How well those are reliable. Unless you don't know about that particular topic, okay, you can't simply believe whatever the results they give, isn't it? That is
Yes,
where
yes.
the reliability comes into picture.
Yeah. Okay, ma'am. Yeah. Thank you, ma'am. Thank you for your wonderful session, ma'am. Thank you.
Okay, yeah. Thank you, sir.
Any other queries from the participants? Okay. I thank all the participants who had a very good interactive session with Madam. So now it's time to conclude the session. So before that, I just want to add a few more points to the question raised by the previous participant. Like the participant asked, what are the research area of MAM? To just add on to that particular point, because I have a direct work experience with MAM for nearly 6 to 7 years. Like whatever the computer domain you are having, so if you just go to RVCE website and see Madam profile, you can see a rich set of experience in all the computer science domain. So like that's why I think even Madam also took some time to highlight like what are the current research area. And this one like why it is possible is I have seen the strong foundation skill, that is what is required for the computer science, like for example C, maybe data structure or any particular programming algorithm and system software. All these are the very basic foundation. And nowadays, if you just see any particular engineering student or this one, they're only relying on the application side, just using the application GPT or copy paste the programming and doing the particular thing. But if you don't have the strong foundation, so you cannot survive in this particular thing. But with a rich set of academic experience, like I have seen Madam teaching COBOL data structure since 20-25 years. And I think in recent days, no one put such effort in understanding the basic. Like once if you understand the basic foundation, whatever the new technology that comes, maybe AI, agentic AI, GPT, or the RAG, whatever is there, so it will be like a cakewalk for those experts who know the basic. So that is what the research skills, what I have personally experienced with the Madam. So with this highlighting this particular thing, I thank Dr. Vijayalakshmi MN ma'am for sharing a insight on the integration of AI with ROS and sharing all the aspect of AI. It was a very beautiful and interactive session, ma'am. Ma'am, I thank you for on behalf of GTBLS, ITW, ATAL, and all the participants. So I just thank you very much for this wonderful session, ma'am.
Okay, thank you, Manju Prasad, for inviting me. It's actually a great privilege again from your side and for this particular session and giving me an opportunity to give this session. And also, I thank the participants for the questions raised, and I hope that with a short span of time, whatever was being given to me, I was able to convey what is the need of AI and how it can be integrated in ROS. Thank you all for giving me the opportunity once again.
Thank you, ma'am. Can we share your contact email details to participants? One or two participants.
Yeah, sure.
So we'll just share your official email ID.
Yeah.
If any participants have any queries
Yes,
or
share, no
for
problem.
any interaction, they can just,
Sure.
Okay.
Yeah, let them contact through email. Yeah, thank you.
Thank you, ma'am.
Thank you, madam. Thank you.
Yeah, thank you.
Harpita ma'am, any instruction for the participants?
Yes, sir. I'll give now.
Okay.
Professors, we'll be having a like tomorrow's session starts from 2 o'clock only. Please do join because tomorrow we'll be having a autonomous navigation in ROS2 session, and tomorrow there will be 3 sessions. It starts from 2 and it will continue till 7:30. After that, we'll be having a valedictory session. It will be there only for 10 minutes. We'll wrap it up very soon. And regarding the assessments in the portal, we have enabled at 6:30 tomorrow. So don't forget. So in that link will be reflected in your ATAL portal itself, because we'll not be able to share the link. It's through the portal only. You have to log into your ATAL portal and you have to take the assessments. So you have to, as soon as you log in and go to the test session, section. So there you'll find a link. So, and before that, there are a set of instructions to be followed. So please read that instructions carefully and take the sessions. Am I clear to all?
Yes, sir.
Yes, ma'am.
But
Ma'am.
sometimes when through
Yes,
the
ma'am.
ATAL portal, yeah, sometimes we have faced through ATAL portal where you post the link, right? Not just you or the other ATAL FDPs wherever we have attended. In case if it is not possible for us to submit it through the ATAL portal itself, so what is the next option we have?
That we have not, that is not there, ma'am. Actually, we have to submit it through the ATAL portal only. You have to take it through the ATAL portal only.
Yeah, because sometimes we face the internet issues at that time because most of them would have been logged in, so it gets usually hanged at times.
Okay.
So that is what we have.
Ma'am, we'll just check with our login as well. If possible, during that condition, can we extend for any duration or can we raise any queries to the ATAL? We'll just let you know. Maybe one or two, this one you might have faced.
Yeah.
We'll just check with that particular
But
option as well.
Once you click on the start session, ma'am, you have to complete it before the stipulated time
Yes.
itself.
Yeah, there will be some
Because
stipulated
otherwise,
time we have to
because
complete it. Yes.
We'll
yeah,
share some
because that
instruction
is
as well, ma'am. What and all the careful this one you have to manage. We'll share that particular thing. So following that instruction, you can try to complete the test.
Sure, sir. Okay, sir.
I
Thank you
don't.
so much.
Ma'am, this tomorrow's session on autonomous navigation will be occurring on Docker setup, ma'am, or you'll give the
The
link?
resource person will let you know. The resource person will let you know, sir. During the session itself, he'll guide you through that.
Oh, okay, ma'am.
Ma'am, and Arpita ma'am, any information on the feedback on the YouTube?
Yeah, I ask them to, and also participants, please give the feedback in the ATAL FTP link.
So we have shared the channel link. So I request all the participants like in the